Assalamualaikum guys. Today I will discuss about a recent code forces problem. The name of the problem is hidden knowledge of the ancients. So what the problem actually says, you will be given n elements. You are given n, k, l, and r. What n represents? N represents the size of the given array. K is a number. L and r are bounds. L is lower bound and r is upper bound. So what the problem actually says, let's say consider this example. Here there are 5 elements. The given k is 2, the lower bound is given 2, and the upper bound is given 3. You have to find such subsequence which length is in between 2 and 3, and the number of distinct element in that subsequence is actually 2. Not subsequence, actually that will be the consecutive subarray. uh, so for this example, what will be our answer? I will show you that in whiteboard. uh, so you are given 1 2 1 3 and 2. Given L and R is L is 2 and R is 3, and given K is 2. So first of all, this is a valid answer because here the length is 2, that is in between the range, and the number of distinct element between this is 2, which is also valid. It is also a valid answer because the number of elements here is 3 and the number of distinct element here is 2. But from 1 to 3, that is not valid because first of all, that is crossing the bound. The upper bound here is given 3, but the total elements here is actually 4, plus the number of distinct element here is 3, which is also not valid. So there is not a valid answer here. 2 and 1 is a valid answer, but 2 1 and 3 is not a valid answer because for that region, the number of distinct element here is 3. 1 3 is a valid answer, but 1 3 2 is not a valid answer, and in such way 3 2 is a valid answer. So here 1 2 3 4 5 elements, 5 subarrays which actually obeys all the or satisfies all the conditions. So the answer will here be 5. And yeah, you're watching the value for the test case 2 is 5. Okay, so how can we actually solve this? uh, let's say consider this example again. 1 2 1 3 2. So we will iterate through all the elements. Let's say now we are now standing in this element. So if somehow we can calculate that uh, how many element here in the left are how many ways in the left here are possible, that will satisfy all the conditions. Let's say that will the possible sub array will contain 3, and what are the number of possible sub arrays that actually satisfies the answer. Here one possible answer is 1 3. Let's say if the given k value is 3 instead of 2, then 3 1 2 would also be a possible answer. Even 3 1 2 1 would also be a possible answer. Here I have not considered about LNR, we will consider it later. But if you have understood it how we will going to solve this, then actually you have understood what we will do. For 3, here there is a valid, let's say the upper value or the current value here is 1 instead of 3, I'm erasing it. So now the upper value here is, let's say 1. We are currently standing in this position. So how many possible subarrays are present in the left, which will satisfy all of the conditions? So one possible answer is this subarray. It is actually following all of the conditions. Here the number of elements in this array is 2, and the number of distinct element here is also 2. This is also a possible answer. Here the total number of elements is 3, which is in between the upper bound, and also the number of distinct element here is 2, which is also following the condition. So for all of the elements here we will do such a thing, but here a thing to concern that uh, how can we actually calculate these optimally, that we are currently standing at a position, and how much element in the left, how much subarrays or how many subarrays in the left are valid in positioning at the left. So how can we do actually it? Okay, one thing you can notice that the number of uh, wait a moment, sorry, here you can see a thing that the number of distinct element will increase as much as we go left. How? Here let's say the number of distinct element is just 1, here the number of distinct element is 2, here the number of distinct element is 2. uh, it will keep the number of distinct element may be same as before, or it may increase. Let's say here is 3, then the number of distinct element will be 3, 1 and 2, that is 3. So as we go left, the number of distinct element actually increases. Let's consider another example. uh, Suppose you are given an array like this: 1, 2, 2, 3, 4, 4, 5, 6. Let's say we are currently standing at here. So the number of distinct element here is just 1, here is 2, here is also 2, here is the number of distinct element is 3, here the number of distinct element will be 4, 4, and that is 5. So here you can see that it is just an increasing uh, array at the left. But let's say we have to find 3 distinct elements. Let's say we have to find just 4 distinct elements. So we can say that it is in between. This array is a possible subarray. Here the number of distinct element is 4, and this also, and we not need to consider whether any such element in the left of that. Let's say here were also 7, 8, 9 and another distinct elements, so it will possibly cause the number of total distinct element is greater than 4. So we need to consider the elements in the left. So now what will we do to properly calculate this? Uh, we can actually yeah, we can actually save the last position of each element's frequency. Let's say for this, the last element, the last position here is just uh, sorry. Okay, I will show you this example so you will understand it better. Here the array is 1 to 1, 2 3 2 1. 1 2 1 2 3 2 and 1. And here the number of distinct elements should be 3 and the range is 2 and 4. So how can we actually do that? We first of all will maintain a map which will actually locate the last position of that element. Let's say mp of 1 here is just 0. mm, Consider it is a zero based indexing array, and here the mp of 1 should be 0 1 and 2, so it will be replaced by 2, and mp of 1 here is 0 1 2 3 4 5 6, so it will be replaced by 6. So why is this important? um, Sorry for interrupting. um, so what we were doing, we said we will actually maintain a map. What the map will store? The map will store the last position of that current element. Yes. And we will also store a set. What that set will do, it will actually save a pair. And what the pair actually consists, the pair actually consists the position what the last element has and that element. I will simulate what will I do. First of all, we are let's say we are standing here, so the mp of 1, say mp of 1 will be 0, and it will locate into the set, so the set will contain 0 comma 1. Okay, then we will iterate here. uh, the mp of 2 will be 1, and the set will contain 1 comma 2. Then we will come here. Here mp of 1 will be replaced by 0 1 2, so it will be replaced by 2, and it will be removed because 1 uh, as this is replaced, it will also be replaced, so it will be 2 comma 1. Why? The position here is 2 and the element here is 1, and this is zero based indexing. Then we will come here, and mp of 2 will be updated 0 1 2 3 s3. As it is updated here, this will be removed, and here it will present 3 comma 2. Okay, and now here this will come to at this position. mp of 3, there is no such element here in mp3, so it is a new element. Here mp of 3 will be 0 1 2 3 4, and the set will be 4 3. Here we that there are 3 elements in this set, so we can say the here distinct element and all distinct elements last position here in. So we can say that uh, this first element here in the set, this 2 actually represents these positions, so actually this is a valid substance. But if aren't valid, it's valid. Why? Because this is the position that our one value we have got. But as we go left, the number of let's say that as we go there, the number of distinct elements selling or it increases. So we can say that here number of distinct elements lost or greater than 3, number of elements is greater than 3. As we have our first 3 elements and we have not got any 4 distinct elements, so we can say that the number here left which represent are also the number of distinct elements that are lost, and here is also 3. For understanding where, let's say here is 4, so we are understanding at here now it's element. Sorry, first of all the MP4 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 will be 0 1 2 3 4 5, and then we put 5 comma 4. We want to say there are 4 elements but need 3 elements, so we need this to form. But what actually represents the actually represents position, so there are 2 elements. Any of the elements left of this actually contain 4 distinct elements, and what will next or second to represents this number actually represents 0 1 2 3. From this from the left of this element there will only 3 distinct elements, so this two actually do these two actually represents from here. Yes, this two represents from this portion from the to the left. It will contain fixing right here, and what these 3 actually represent that's it actually represents from here to the left there will be present 3 distinct elements. So from here there are 4 elements. If we take the left, we will get 4 distinct elements from here to here, and if we take from 2, so if we take from 2 to 4, we will get 3 distinct elements. Let's say here there were a number, and we can say that for this 2 to 4 it will give a valid subsequence, and for that number in between of them it will also give a valid subsequence. For this portion, as this will contain 4 distinct values, it will not considered as a valid subsequence. Right? From 2 it will become as a valid subsequence. So instead we will talk about thing set is again we said it will I have found in our, so if I have not found in our, then if first of all if I have found in our main, I will place and I will back and do the index and of the index as well. I have updated this, then I have pressed E for that and return the new where is set. If the set given, we actually consider what size is 3 and the set size is 4, on t equals to 3. We consider when t equals to false, it will increasing steadily. Let's say it is like this, and it will increase, So we need to edit some for and this is on there. So we need to consider this portion. Import, and if we somehow know that it is greater than k, we consider whatever there is the, so we do just this portion. So instead of so in this one we will be here also will bring that set. Let's say here I use 6 on 7, and here this more than 5, so we will use the first of 20 to consider any element we just increase the size 30 increase and breaking element which we don't need. And again the height here low represents the size of the lowest value substance. Here 9.3 the lowest value of the substance is 3 plus 3 to 1 as 3 silent and 8 values substance, and is the lowest. Here 2 1 2 also 3 leading but is not the lowest. What is highest? Here has 3 2 1 1 verified. So how early we will get, but I'll say we are responsible this. Let's say when we're here the size of let's say is 3 is here. The size of the 3 when we were at the position, so when we were at the 3 is high. When the limit let's say will see, and okay, I will say that the value say during the are valid. So the lowest value, so the lowest has value are it the for has the same whatever. uh, so actually what we were doing uh, in that code, when the size is actually k, the set size is actually k. Here I have written it again. Here we will looking that at this, when we are at currently 3, the set size is actually 3. So what is the what will be the minimal length of the valid subsequence or subarray? That is actually the last position of the uh, first element present in the set. So here in the first position of the set, we are just watching 2 and 1. So here 2 represents actually this is the last valid position, and from here to here that is a valid subsequence or subarray. It will also be a valid subsequence or subarray. It will also be a valid subsequence or subarray. Why? We have found at most 3 distinct elements from here to till there. We have not got 4. So as we have talked it earlier, that as we go lefter, here 3, there is just one a distinct element. From here to here there are 2, from here to here there are 3, from here to here there are 3, from here to here there are 3. So it will always be increasing, not decrease at all. So as we have found first 3 here, so we can say that from here to here, and it is the first element where we have found the first 3. Let's say like this, it is the position where we have find first 3, and later after it kept constant, or it may increase, but we have not found anything such that the number of distinct elements has been increased to 4. So we can say when we have found k, the low will represent what? The low will represent the least size of that valid subsequence. And what is the least size? That will be, what is the current position we are locating, minus the position of the first element of the set, and that is 2. Here it will be 2, so we have written it like this: st began first, and y plus 1, because this position minus this position and plus 1 will actually represent the size of this array. And now you are actually understanding why we have put the last position here, because by putting last position here we are actually being able to calculate the number of distinct element in least case possible. If we put the position of 1 here is just 0, then we would possibly could not get the least uh, subarray length which is actually valid. So by this we are actually being able to calculate the least possible size of the uh, candidate subsequence or valid subsequence. And here we have found the least size of the valid subsequence is just position of this. What is this? 0 1 2 3 4, 4 minus 0 1 2, here that we have found here, and plus 1, and that is 3. Yes, that is 3. That is the least possible subsequence we can get. We can get also 4, we can get also this. And how we will calculate this? We will simply calculate it by I plus 1. Why? That is 0 1 2 3 4, but we will get uh, possible of subsequence of length just 5. So that is I equals to I plus 1, that is 4 plus 1 equals to 5 here. Okay, it is the case when the number of element in the set is just equals to k. So when it actually becomes 4, let's say here, when we come here, the MP of 4 equals to be 0 1 2 3 4 5. So MP of 4 mp of 4, it will be now 5, and the set will contain 5 comma 4. So here you are now watching that the number of elements in the set here are present is 1 2 3 4. Okay, if it was 4 plus 1 equals to 5, then we would possibly erase the first element, but here that is just equal to st of size is equal to k plus 1, so we will consider this case. So what this case actually says, this case actually says that what will be the minimal position, sorry, what will be the minimal number of the valid array that we can make, that is the current position minus this. How can we get that? We can get that by next of set begin. We can get next of set begin and first, as we are taking the first element of this set, so we can get this by next of set begin first. Thus we can get this and plus 1. Why? And that is valid. Let's say you are now at 4 and the number of distinct element here is obviously 3, because what, here 4 is a distinct element, 3 is a distinct element, 2 is a distinct element, and here we are putting the last element there positioning in. So we can obviously say that from 5 to the position 3 in this array there are obviously 3 distinct elements. So the minimal position of, sorry, so the minimal number of size of the valid subarray will be this 5 minus this 3 plus 1. And what will we get? We will get 5 minus 3 plus 1, that is what, 3. We will get this subarray. And what will be the upper value of the valid subarray length? That will be this. Why? Why I have written this? Here you can see I have written it, yes, the upper portion of the valid subarray length is, now we were locating at here, so the current I value is 0 1 2 3 4 5 5 minus st begin first, that is 2 0 1 2, yes, 0 1 2, and that will be the highest valid subarray length. And what will we get? We will just get 3. That means we cannot go to the left to get the valid subarray, and